I was sitting in a neuroscience lecture last week, completely fascinated as my professor explained how our brains process information, when a student raised her hand and asked what I thought was a brilliant question. She said, "Professor, I keep hearing about chemical impulses and electrical impulses in the brain, but I honestly have no idea what the difference is or why it even matters." The entire class seemed to perk up because, let's be honest, most of us were thinking the same thing. As someone who's spent years studying psychology and neuroscience, I realized this is one of those fundamental concepts that we often take for granted, but it's absolutely crucial for understanding how our minds actually work. Before we dive into this fascinating topic, I want to remind you that if you're interested in psychology content that breaks down complex concepts into understandable insights, make sure to subscribe and hit that notification bell. I post new videos every week exploring the incredible world of human behavior and brain function. And trust me, once you start understanding how your brain actually operates, you'll never look at your thoughts, emotions, and behaviors the same way again. According to neuroscientific research, our brains operate through two primary types of communication systems. Think of your brain as the world's most sophisticated communication network, with about 86 billion neurons constantly sending messages to each other. These messages travel in two distinct ways, through electrical impulses and through chemical impulses. Both are absolutely essential for everything you do, think, and feel, but they work in completely different ways and serve different purposes. Let's begin with electrical impulses, which are probably easier to understand because we can relate them to the electricity in our homes. When a neuron gets stimulated enough, it generates what scientists call an action potential. Picture this like a wave of electrical activity that races down the length of the neuron at speeds that can reach up to 120 meters per second. That's incredibly fast when you consider we're talking about microscopic cellular structures. This electrical impulse is created through a fascinating process involving charged particles called ions. Normally, a neuron maintains a resting potential of about negative 70 millivolts. When the neuron gets stimulated, channels in its membrane open up, allowing sodium ions to rush in and potassium ions to flow out. This creates a cascade effect that travels down the entire length of the neuron like a domino effect, but much faster. Here's what's really interesting from a psychological perspective. These electrical impulses are what allow you to have immediate reactions. When you touch something hot and instantly pull your hand away, that's electrical impulses at work. When you see a car coming toward you and immediately step back, electrical impulses are carrying that visual information from your eyes to your brain and then to your muscles at lightning speed. But here's where it gets really fascinating. When that electrical impulse reaches the end of the neuron, it hits what's called a synapse, which is essentially a tiny gap between neurons. And this is where chemical impulses come into play, because electricity cannot jump across that gap on its own. Chemical impulses involve neurotransmitters, which are essentially chemical messengers that carry information from one neuron to another. When the electrical impulse reaches the end of a neuron, it triggers the release of these neurotransmitters into the synaptic gap. These chemicals then travel across the gap and bind to receptors on the receiving neuron, potentially triggering a new electrical impulse in that next neuron. What's crucial to understand is that this chemical communication is much more complex and nuanced than electrical communication. While electrical impulses are basically on or off, like a light switch, chemical impulses can vary tremendously in their effects. Different neurotransmitters can have completely different impacts on the receiving neuron. Some excite it, making it more likely to fire its own electrical impulse. Others inhibit it, making it less likely to activate. From a psychological standpoint, this chemical communication system is absolutely fundamental to understanding human behavior and mental health. Let me give you some concrete examples that will help this make sense in your daily life. Consider dopamine, one of the most well-known neurotransmitters. When you accomplish something you've been working toward, when you eat delicious food, or when you experience something pleasurable, dopamine gets released in specific brain circuits. This chemical impulse doesn't just carry information, it actually influences how you feel and what you're motivated to do next. The chemical nature of this communication means it can create lasting changes in your brain's chemistry, which is why positive experiences can improve your mood for extended periods. Serotonin provides another excellent example. This neurotransmitter is heavily involved in mood regulation, sleep patterns, and even digestion. When serotonin levels are optimal, you typically feel emotionally balanced, sleep well, and have a healthy appetite. When serotonin levels are disrupted, which can happen due to stress, poor diet, lack of sunlight, or various other factors, you might experience depression, anxiety, sleep problems, or digestive issues. This is chemical communication directly influencing your psychological state. The timing differences between electrical and chemical impulses also have profound psychological implications. Electrical impulses happen almost instantaneously, which is why you can react to immediate dangers so quickly. But chemical impulses can have effects that last much longer. When you experience trauma, for example, the chemical changes in your brain can persist for hours, days. For example, the chemical changes in your brain, or even longer, which helps explain why traumatic experiences can have such lasting psychological impacts. This brings us to an important point about neuroplasticity and learning. While electrical impulses handle immediate information processing, chemical impulses are crucial for creating lasting changes in your brain. When you learn something new, practice a skill, or form new memories, chemical processes strengthen or weaken the connections between neurons. This is why repeated practice is so important for learning, and why certain experiences can create such lasting impressions. Understanding this distinction also helps explain how various psychological interventions work. Cognitive behavioral therapy, for instance, helps you develop new thought patterns through repeated practice, which gradually changes the chemical communication patterns in your brain. Meditation and mindfulness practices influence neurotransmitter levels, particularly increasing GABA, which promotes calm and relaxation, and potentially boosting serotonin levels. The interaction between electrical and chemical impulses also explains why psychological states can be so complex and sometimes seem contradictory. You might rationally know that something isn't dangerous, but still feel anxious about it. This happens because different brain circuits, using different combinations of electrical and chemical communication, can process the same situation differently. Mental health medications work primarily by influencing chemical impulse transmission. Antidepressants, for example, typically work by affecting serotonin, dopamine, or norepinephrine levels in the brain. They don't cure depression by changing electrical activity directly, but rather by modifying the chemical environment in which neurons communicate. This is why these medications often take several weeks to show their full effects, as the brain's chemical balance gradually adjusts. Interestingly, physical exercise influences both electrical and chemical impulse systems. When you exercise, you increase electrical activity in motor neurons, but you also trigger the release of endorphins, which are chemicals that naturally improve mood and reduce pain perception. This dual effect helps explain why exercise is so effective for improving mental health. Sleep provides another fascinating example of how these two systems work together. During sleep, electrical brain activity changes dramatically, shifting through different patterns during various sleep stages. Simultaneously, chemical processes clear waste products from brain cells, consolidate memories, and reset neurotransmitter levels for the next day. This is why poor sleep affects both your cognitive function and your emotional regulation. The development of these communication systems also has important psychological implications. In childhood and adolescence, both electrical and chemical impulse systems are still developing, which helps explain why young people's emotions and decision-making can seem so intense and sometimes unpredictable. The prefrontal cortex, which relies heavily on refined chemical communication for executive functions like planning and impulse control, doesn't fully mature until the mid-20s. Stress provides an excellent real-world example of how electrical and chemical impulses interact in ways that affect your daily psychology. When you encounter a stressor, electrical impulses quickly carry sensory information to your brain. If your brain interprets this as threatening, it triggers chemical releases, including cortisol and adrenaline. These chemicals prepare your body for action, but they also influence your thinking, making you more alert, but potentially less able to engage in complex reasoning. Understanding these processes can actually help you develop better coping strategies. When you're feeling overwhelmed or anxious, you can use this knowledge to your advantage. Deep breathing exercises, for instance, influence both systems by changing electrical patterns in your brain and promoting the release of calming neurotransmitters. What's particularly fascinating is how social interactions influence both electrical and chemical impulse systems. When you have positive social experiences, your brain releases oxytocin and other bonding chemicals. When you feel socially rejected, your brain's pain centers activate through electrical impulses. But the emotional impact comes from chemical changes that can last much longer than the initial electrical activity. This understanding also sheds light on why habits can be so difficult to change. Habits involve well-established patterns of both electrical and chemical communication. The electrical patterns allow for quick, automatic responses, while chemical reinforcement systems make these patterns feel rewarding or necessary. Changing habits requires patience because you're essentially rewiring both electrical pathways and chemical reward systems. Looking at this from a broader psychological perspective, the interplay between electrical and chemical impulses helps explain the incredible complexity and adaptability of human behavior. We're not simple input-output machines responding only to immediate stimuli. Instead, we're dynamic systems where past experiences, current chemical states, and immediate electrical processing all combine to influence our thoughts, feelings, and actions. This knowledge has practical applications for personal development as well. Understanding that lasting change requires chemical as well as electrical modifications helps explain why sustainable personal growth takes time and consistent effort. Whether you're trying to develop new social skills, overcome anxiety, or build better habits, you're working with biological systems that need time to establish new patterns. The difference between chemical and electrical impulses isn't just an academic distinction. It's fundamental to understanding how your mind works and why you experience the world the way you do. Electrical impulses provide the speed and immediacy that allow you to navigate your environment effectively, while chemical impulses provide the depth, complexity, and lasting effects that make you capable of learning, growing, and experiencing the full richness of human psychology. By understanding both systems and how they work together, you gain insight not just into neuroscience, but into the very nature of what makes you uniquely human. This knowledge empowers you to make more informed decisions about your mental health, personal development, and overall well-being.